Okay, everyone, this is how to divide rational expressions. So let's suppose that we have a rational expression like the following. So 2x squared minus 8x over x squared minus 3x minus 10 divided by 4x squared divided by x squared minus 9x plus 20. So dividing rational expressions is almost exactly the same thing as multiplying rational expressions. In fact, just like when you're doing a division of fractions question, you could actually turn it into a multiplying fractions question, in this case a multiplying a rational expressions question. That's what we're going to end up doing to actually solve this. So just like any question of this sort, the first thing we're going to want to do is to check to see if things are factorable, and if they are, then factor it. So I want you to notice that we do have several things that are factorable here. For example, in our first expression, the numerator can be factored into 2x times x minus 4, so we common factored out 2x. Next, the denominator of our first expression there can be factored. So I'm going to do the kind of work off to the side here. We have a sum of negative 3, a product of negative 10. And so two numbers that add to give us negative 3 and multiply to give us negative 10 are negative 5 and 2. So that's going to factor into x minus 5 times x plus 2. Okay, we have divided by, well, the top of the second expression could not be factored, 4x squared is already factored, but we can factor the bottom, and again, I'm going to do the work off to the side. So our sum is negative 9, our product is 20, so the two numbers are negative 4 and negative 5. And that means it's going to factor into x minus 4 times x minus 5. So now that we've fully factored this, this is where we're going to start to treat this closer to like a regular fractions problem, right? A regular dividing fractions problem. So you might remember that in order to divide two fractions, you can turn it into a multiplication problem. Now, to do that, all you need to do is basically take the reciprocal of this particular expression, the second expression. So we're going to want to take the reciprocal of that second expression to turn it into a multiplication problem. So let's see what that's going to look like. So the first expression is going to be the same, 2x times x minus 4 over x minus 5 times x plus 2. But this time we're going to multiply by the reciprocal of the second expression, which is going to be x minus 4 times x minus 5 over 4x squared. So we just flipped it. We took the reciprocal. Okay, at this point we have a multiplying rational expressions problem, and we've already got everything factored out, so all we need to do is start canceling out common factors wherever possible. So you might notice that we have a factor of x in the first that's going to cancel out with a factor of x in the second expression. We also have a factor of x minus 5 on the top of the second expression and on the bottom of the first expression that will cancel. Okay, the two x minus 4s at the top cannot cancel because they're both in the numerator, right? They won't cancel. They're going to actually combine, as we're going to see in a moment. But we do have a 2 and a 4 that can be reduced, right? So we're going to reduce the 2 and the 4 to just the 2 on the bottom. So we basically divided both of them by 2. And what's that going to leave us with? Well, we're going to have the 2x minus 4s up top, and since we're multiplying x minus 4 by x minus 4 essentially, we're going to have x minus 4 squared up top. We have the 2 and the x that's left over, that becomes 2x, and then we have a factor of x plus 2 at the bottom. So that's what that is going to simplify into essentially. So this entire dividing rational expressions question simplifies into x minus 4 squared over 2x times x plus 2, but we do need to deal with the restrictions now. So for the restrictions, we can easily tell from our final expression that we have restrictions of x is not equal to 0 from this guy here, okay? But we also have x is not equal to negative 2 from here, because if x was negative 2, that factor would be equal to 0. But that's not all. So in dividing rational expressions problem, we need to look at the factored form. So where we have everything factored, we need to look for the denominator, or look in the denominator of the first expression, right? So we've already covered this guy up here, but we also need to cover this guy up here. So that suggests that x is not equal to positive 5. But we also have to look at the denominator and numerator for our second expression and see if there's anything new there. So for this expression right here, we have to see if there's anything new at all from the numerator and the denominator, because since we end up flipping it, right, what was on the in the numerator becomes the denominator and vice versa. So we still can't have x be certain values that would give us 0 in the numerator, okay, because then when you take the reciprocal, you'd have some issues. So according to what we have up there, we have x is not equal to positive 4 as well. So x is not equal to 4 is also a restriction from this guy right here. Okay, and I think that's it for the restrictions. So 2x squared minus 8x over x squared minus 3x minus 10 divided by 4x squared over x squared minus 9x plus 20. That simplifies into x minus 4 squared over 2x times x plus 2, with restrictions of x is not equal to 0, -2, +5, and 4. So that's dividing rational expressions, guys. Hope this helps.